Good evening. So today I will discuss about the multiplication law of probability. So before we discussion about the multiplication law of probability, we just remember conditional probability. First, you think conditional probability. Okay. The first you think conditional probability. Just to remember here, what is the meaning of the conditional probability, and that is given here. The for two events A and B, for two events, one event is A and another event is B. Just see here. When condition is applied, that means this is the symbol of condition, and taking the probability symbol, this is A by B. That means what is the representation of this one? Probability A slash B. That is represent as conditional probability. That means probability two events were mentioned A and B. So conditional probability represents here A by B, or probability is also conditions represent B by A. This is the condition symbol, and this is also condition symbol when two events are such represented here. The first of all, probability B by A denotes the probability of occurrence of B when A has already occurred. A has already occurred. Already occurred. Right? We need to find the probability of B. We need to find the probability of B, but given that A has already occurred, and that is represent probability B by A and named as the conditional probability. When A has given already, before we finding the probability of B. Just similarly here, B has already occurred. Already occurred. But we need to find the probability of A. This is our process to find the probability of A. And this generally representation of the conditional probability when B has already occurred, and we need to find the probability of A. So there are two cases we arise, and just to represent here, probability of B by A. Here represent A has already occurred, right? A has already occurred. And that is also we mention probability of B by A, that is probability of A intersection B divided by probability of A. Okay. When it conditional probability, also we can say that that is a multiplications probability. Just to multiply here. Probability of A intersection B, and that is we represent probability of B by A into probability of A. So this is called as the multiplication theorem of probability. This is called multiplication theorem of probability. Multiplication theorem. So this is called multiplication theorem of probability. Just to remember, this is the conditional probability, and we can say that is also the multiplication theorem of probability also. Okay. So here also this multiplication theorem is also called as the dependent probability. dependent probability, because here when you need to find the probability of B, that depends upon the probability of A, because this type of probability we called as the dependent probability. And another was the independent probability. And multiplication theorem is called as the dependent probability, and that we mention here probability of A intersection B, that is equal to probability of A into probability of B by A. This multiplication theorem. And this is the multiplication theorem, probability B by A and probability B. So this is called as the dependent probability. And just to define here, independent probability. Independent probability. So what is the meaning of the independent probability? So I think here, what is independent? That means does not depend upon the events. Here, A and B, we consider two events. So A events and B events does not depend on itself. That's why A and B are called as independent probability. So what is the formula of independent probability? Probability A intersection B also we represent for probability of A into probability of B. That is called independent probability. So dependent probability and independent probability. Dependent probability basically called as the multiplication theorem, and independent probability is called as the probability A intersection B, which is equal to probability of A into probability of B, right? And just to consider one example here for independent and dependent probability, right? Okay. Just an example here represent two cards are drawn in successive from a pack of 52 cards. Find the chance of the first is a king, second is a queen if the first card is replaced. And second point I also show that it is not replaced. So just to remember, playing cards represents us total number of cards is 52. In playing cards, the available total number of cards is 52, right? Total number of playing cards. Total number of playing cards. Playing cards. And that is represents us 52. But question is that the probability drawing a king out of 52, we draw a card. One card is drawn here. Then what is the probability of this card if this card is a king? And this card is represented as king. So what is the probability of king? So there are 4 kings are available in our playing cards. So probability of king we can define here. So what is the probability of king? 4 kings are available in the playing cards. That is in favor of king, that is 4 out of total is 52. So that is 1 by 13. So king probability is 13. But question is here, two cards are drawn here. One card, if we replaced, we can receive and replaced again into the playing 52 playing cards. What is the probability? If this card is received again replaced, then what is the probability of this card? If the card is replaced, the pack will again have a 52. If we can replace this card, then again total playing cards is also 52. Because you drawn one card, but again you replace this also card. So total possible outcomes is not changes here, remains as 52. What happens here? Total outcomes is 52, but second card is also we want to a king. So what is the probability of that king? That is also same. That is 152. Probability of king. That is also 4 by 50. Because that is replaced, again draw, and that is also 1 by 30. The question is here, two events being independent. The probability drawn, both the cards are successive. If two events are independent, if these are independent, this event is independent. So what happens? The probability of both cards, probability of king slash king, king condition king, and that is independent both are. So probability of A into probability of A. That is 1 by 13 into 1 by 13. And that value will produce, that is 1 by 169. 1 by 169. That is the one case. When it is replaced, another case. Second case is that is not replaced. Not replaced here. Card is drawn 1. The first probability you already defined here. Probability of king already defined, that is 4 by 52. 4 by 52. Because out of 52, one card is already drawn here. So remaining card is 51. Just see. And this card is not replaced here. Not replaced. So now the total card available is 51. Again, another card is drawn here, and you need to find the probability of king. If card is not replaced, it's not replaced. What happens here? Probability of king, that is 3 by 51. See here. These are the independents. So probability of both the card here, probability of both the card, that is 4 by 52, 3 by 51. 4 by 52 into 3 by 51. This is your probability for the case when it is not replaced. That is 4 by 663. Okay. So this is probability of conditional probability or multiplication here. Okay. So we'll see again some examples of the conditional probability next class. Okay.